Sheet metal, exercise 3, with the focus, bend, unbend and rebend, and bead. The bend command can be used to create linear bends using sketch lines. Limited bends can also be created. The length of the line controls the width of the bend. And so, in just a few steps, a rectangular plate becomes a part chute. The inserted beads run across the bend. The unbend and rebend commands can help here. Turning a bead upside down can sometimes cause problems, but the issue is easily identified. Default settings. Create a new sheet metal part. As always, we will start with the default settings. If the sheet metal application is active, you will find the default settings under Menu, Preferences, Sheet Metal. Select a material thickness of 1 mm, and the same for the bend radius. As shown in the first exercise, the BRT value is therefore 1. Also select 0 mm for relief depth, and 3 mm for relief width. To calculate the stretched length, I recommend using the formula method, with the DIN 6935 option, as explained in the first exercise. Now you're ready to go. Create Base tab. There are many ways to create a sheet metal part. As in the last exercise, the sheet metal part is usually created first, and then a flat pattern is generated from it. In this exercise, you will learn the reverse method. You start with the flat pattern, in this case a simple rectangular plate. Start the tab command, and create a sketch. A rectangle is sufficient for this component. Position the rectangle centrally on the x-axis. This will allow you to use the XZ plane of the coordinate system for mirroring later on. Create bend. Start the bend command, and create a sketch. The Use Work Part Origin option sets the origin of the sketch to the origin of the work part. The sketch may only contain a single line. The length doesn't matter, in the case of an unlimited bend. After finishing the sketch, you can enter the bend angle. Reverse direction allows you to reverse the bending direction. With reverse side, you can now choose which side will be the bending leg, and which will remain fixed. Oh, I need to correct the bending angle. If the Extend Section option is disabled, the bend ends at the end of the sketch line. Activate this option to create a continuous bend. Under Inset, you can define the position of the bend relative to the sketch line. This is similar to the flange command. Viewed from the bent flange, this is the inner edge, and that is the outer edge. If you want the sketch line to define the outer edge of the bend, select the option Outer Mold Line Profile. If you want to define the center of the bend, select Bend Center Line Profile. And if you want to define the inner edge of the bend, select Inner Mold Line Profile. If the flange should lie inside the line, select Material Inside. And if it should lie outside, select Material Outside. For the exercise, select the Outer Mold Line Profile option. The bend parameters display the default settings for the bending radius and neutral fiber. We will change these settings later. The settings for relief doesn't matter, because the bend is unlimited. With the mirror feature, the bend can now be mirrored. Non-extended bending. If the line does not run from edge to edge, and the extend section option is deactivated, the flange is cut out of the sheet metal. The length of the flange therefore depends on the settings for the stretched length. The width of the flange corresponds to the length of the line. Slots can be created on the sides of the flange, using the relief function. I recommend the round setting for both laser cutting and punching. With this knowledge, you can now create the side flanges. Start the bend command, and create the required line. The flange has a width of 32 mm, and a distance to the center of 90 mm. This time, the material is on the outside, and the sketch line should not be extended. The slot has a width of 3 mm, and a radius at the end. Now this flange can also be mirrored. And the final bend is the kink across the component. A short line, with a distance of 33 mm is sufficient. Activate the extend section option again, so that the bend runs from edge to edge. The bending angle is 21 degrees. If necessary, you may need to correct the direction and side again. This area is now moved, so it is the flange. The sketch therefore defines the outer edge of the bend. Unbend. To increase the stability of the component, 2 beads are to be inserted. But they run across the bend. However, the bead command can only create beads on flat surfaces, so the bend must first be bent back again. To do this, use the unbend command. Select the fixed surface, and then in the second step, select the bend that is to be bent back. And bang, the sheet metal is flat again. Now you can create holes or beads in the bend area, which can then be bent again, using the rebend command. Create bead. Start the bead command, and create a sketch. This time, the sketch may contain not only lines, but also arcs. The lines and arcs must be tangential. The sketch may also contain several unconnected lines and intersecting lines. As soon as you finish the sketch, the beads are created. You can set the depth and radius here. Of course, the depth must be smaller than the radius. The blend bead edges are activated here. They are necessary for production. Without these blends, the sheet metal would tear at the edge. The edge radius should be greater than, or at least equal to the sheet thickness. Various cross-sections can also be selected, as well as the design of the ends. Here, the minimum distance between the machining tools can be set. This has no effect on this design, but a check could be created in the HD 3D tool using this setting. However, that would be a completely new topic. Back to the exercise. Start the bead command. And create a line that defines the start and end of the bead. You can mirror the bead later, or mirror the line in the sketch now. This has the advantage of allowing you to dimension the distance directly. Finish the sketch and select the settings shown. The bead runs now over the flat bend. Now the flange can be bent again, using the rebend command. Again, select the area that is fixed, and then the bend. So now, the bead runs over the bend. With unbending and rebending, beads can also run over bends. But, as we see in the next chapter, the bending radius must be greater than the depth of the bead. Reverse the direction of the bead. At the next design meeting, it is criticized that the bead is on the wrong side. If the part were to be screwed on as planned, it would not lie flat. However, if the direction of the depth is reversed in the bead command, an error message appears. But, why? Let's take another look at the finished bead. It has a depth of 3 mm. The bending radius over which the bead runs has an outer radius of 2 mm. The bead therefore has an outer radius of 2 plus 3, which together equals 5 mm. If the depth of the bead is reversed, the radius is calculated as 2 minus 3. The radius would therefore be minus 1 mm. That cannot work. The bending radius must therefore be greater than the depth of the bead. That's why you should change the bending radius to a local value of 4 mm. And just like that, the depth of the bead can be changed. Before I show you a little idea for the bend command at the end, the missing holes still need to be drilled. Create holes. In the modeling group, activate the More Gallery button. Now the hole command can also be started in the sheet metal application. The drilling command would be explained in detail in the modeling course, so here are just a few tips. With the through body setting, the opposite flange is also drilled at the same time. The last commands can also be started by clicking in the graphics area. The very last one can also be started with the F4 key. And here, it is possible to mirror the point. This not only saves the mirror feature step, but also allows the distance to be dimensioned directly. Is there anything else? Yes, the edges still need to be broken. Conclusion. With the bend command, the material of the cut can be used directly. This results in parts that are very easy to manufacture. Another example is this end cap for a pillar. It consists of a simple square plate. Then one corner is bent and patterned. All that's missing now is the hole for the screw. And the end cap is ready. Remember, if something is easy to design, it is usually also easy to manufacture. Well, that's it for now. If you have any questions or requests, please write in the comments, or send me an email directly to info@LearnNX.com.